Okay, let's dive right in. We are standing right on the edge of the next huge technological leap, and it's being driven by two massive forces coming together: 6G and artificial intelligence. And look, this isn't just about making our phones a little bit faster. We are talking about building an entirely new kind of reality, a future where our digital lives and our physical world literally merge into one seamless experience.
I mean, seriously, just pause and think about that for a second. Imagine a world where that line between what's real and what's digital just evaporates. That is the whole promise of this cyber-physical world, a concept that totally sounds like science fiction, but it is fast becoming the actual blueprint for the 2030s.
So, what does this actually look like in the real world? Well, research from places like Ericsson paints a pretty stunning picture. We're talking about massive, interactive, 4D digital copies or twins of entire cities. You could manage traffic or utilities inside a perfect virtual replica. Or think about truly autonomous mobility, where cars, drones, and buses are all talking to each other all the time. Then you've got wide area mixed reality, which basically layers a digital world right on top of our physical one. And maybe the wildest one of all, an internet of senses that could, one day, transmit touch, taste, and even smell over the network.
So, yeah, this brings us right to the core idea: this new cyber-physical world. It's a reality where people, physical objects, and digital systems are all interacting constantly and in real time. This isn't just a small step forward, it's a complete revolution in how we're going to experience and shape our own environment. And what's holding all of this together? What's the foundation for all of it? Yep, it's 6G. It's being designed from the ground up to be the platform that makes this whole fusion possible. It builds on what 5G can do, sure, but 6G is the essential bedrock that's going to support a society that's not just more efficient, but hopefully a lot more sustainable and human-friendly too. Okay, so how in the world do we actually build this future? Well, it's not some single magic bullet. Instead, it's a trio of really powerful technologies that have to work in perfect harmony. So let's break down the engine that's going to power this whole new world. First up, you've got 6G itself. The best way to think about it is like an ultra-fast, super reliable superhighway for data. We're talking speeds in the hundreds of gigabits per second, with response times, what the engineers call latency, of under 1 millisecond. That is, for all practical purposes, instantaneous. And that's absolutely critical for a world where digital and physical actions have to be perfectly in sync. But here's the catch. A highway that massive and that complex, there's no way humans can manage it. Industry analysis says it's literally impossible. And that's where AI comes in. You see, 6G networks are being designed to be AI native. What that means is AI is basically the brain of the network. It turns it into this self-learning, self-healing, and self-optimizing ecosystem that can handle billions of devices and a constant flood of data without ever skipping a beat.
And finally, there's the element of speed, but local speed. You see, sending every little piece of data to some far-off cloud server just takes too long for things like autonomous cars or augmented reality. That's where multi-access edge computing, or MEC, comes into play. It's all about processing data right there at the edge of the network, super close to where it's actually created. That's how you get that crucial real-time response.
So the real magic here is how these three work together. A simple analogy really helps it click. Think of 6G as the body's giant nervous system, carrying signals absolutely everywhere. Edge computing, that's like the local reflex action. You know, like when you pull your hand from a hot stove before your brain even has time to process the pain. And AI? Well, AI is the brain, making sense of all those signals, learning from them, and making the smart decisions for the whole system. Now, a system with a global nervous system and an AI brain. I mean, it sounds incredible, right? But with that much power comes some immense challenges. This new reality brings with it a whole new set of very, very serious problems. We're building this thing, but can we actually control it? And maybe more importantly, who's responsible when things inevitably go wrong? This quote from an ITU report, man, it just hits the nail on the head. When an AI-controlled car crashes or a 3D printed building has a flaw, who's at fault? Is it the person who wrote the code? The person who owns the car? The company that built it? The lines of who's responsible get incredibly blurry in these super complex, interconnected systems.
And these challenges, they run deep. First, you've got the black box problem. Some advanced AI can make decisions in ways that, well, even the people who made it can't fully explain. If you don't know why it did something, how can you hold anyone accountable? Then you've got algorithmic bias.
This is where AI learns from our own flawed data and ends up just amplifying real-world discrimination. And finally, in a world with trillions of connected devices, the risk to our data privacy and security just becomes monumental. So look, these are not just questions for a philosophy class. They've kicked off a global race to create the new rulebook for this new era. Nations all over the world are scrambling to figure out how to govern AI, trying to balance that need for innovation with the urgent need for safety and fairness. Now, what's really fascinating here is seeing the different paths everyone's taking. The European Union is going for this really comprehensive risk-based law, the AI Act, that actually outright bans certain uses of AI. The UK, on the other hand, is taking a more flexible, pro-innovation approach, basically letting existing regulators handle it. And meanwhile, the United States is using a mix of sector-specific rules, executive orders, and this non-binding AI Bill of Rights.
And this chart, wow, this chart really tells the story of how urgent this has become. According to data from the Stanford AI Index, the number of laws passed with the words artificial intelligence in them jumped from just one in 2016 to 37 by 2022. That's an absolute explosion in legislative attention. It just goes to show how seriously the world is taking this.
So, as we start to bring this all together, it's crystal clear we're not just talking about technology anymore. We are actively designing the nervous system, and yes, the brain of our future society. The stakes just couldn't be any higher. And if you're ever wondering about the momentum behind all this, just follow the money. This isn't some niche project. Projections show that AI, just within the telecommunications sector alone, is going to be a nearly $49 billion market by 2033. That is the kind of massive economic force that builds futures, and it builds them fast. So here's the bottom line. This cyber-physical world isn't some science fiction movie. It is being architected right now, in labs, in boardrooms, and in government chambers. The technology is accelerating, and the rules are being written as we speak. And that leaves us with the ultimate question. How are we going to make sure that this incredible, powerful, interconnected future is also safe, fair, and ultimately built to benefit everyone?